Okay, question 7. The figure below shows a fridge or a freezer compartment. The temperature of the air inside the freezer compartment is -5. The air inside the fridge forms a convection current when the fridge door is closed. Explain why. So this is a command word. Explain is worth 4 marks. So it's worth having a bit of a plan for a longer answer question. Convection currents. So convection currents are when we have heat or hot air, or it can be any fluid. So we've got the rise and we have a fall. Why do they happen? Well, it's because the air or the fluid at the bottom is equals more dense. So the particles here are going to be closer together. So let's just draw it as a gas for now. And at the top, our fluid equals less dense. So something like that. So that's what happens with a convection current. So let's see if we can figure out why we get a convection current in this fridge. So first off, we've got our freezer at the top. So that's going to be the more dense. So it's going to be cold here. So more dense. So that is going to drop here. So this more dense air is going to fall to the bottom, and then we're going to have the warm air because we've got some food in here. So when you put your food in your fridge, obviously the food is normally room temperature when you put it in. So that's going to be the less dense. So that's going to rise up. So the warmer, less dense is going to rise. So let's try and explain this. So the air inside the fridge forms a convection current when the fridge door is closed. So we could say that the air at the top of the fridge is colder, so its particles are closer together, and in brackets more dense than the air at the bottom of the fridge, which is warmer. So if it's warmer, the particles are going to be spread out, so less dense. Always got to this point where I need to probably start rereading. The air at the top of the fridge is cooler, so its particles are closer together than the air at the bottom of the fridge, which is warmer, less dense. The cool air will sink towards the bottom, and the warm make sure I actually can read it, less dense air will rise to the top. And that is a convection current, which is describing what's happening here. So we'll just read it back. The air at the top of the fridge is cooler, so its particles are close together than the air at the bottom of the fridge, which is warmer, less dense. The cool air will sink towards the bottom, and the warm, less dense air will rise to the top. Does that answer this question? Why is the convection current form? Yes, it does. All right, and I think we'll get the 4 marks for describing this cycle. So again, this plan just really helps you do that. The table below shows information about 4 fridges. Householder concludes that the energy used in 1 year is directly proportional to the volume of the fridge. All right, directly proportional. We know that that means as one value doubles, so does the other. So equal rates of increase. Explain, so give a reason why her conclusion is not correct. Use the data from the table. So we've got to use that table data. So let's have a look. We're looking for these doubles. So we've got 250. So 250 litres equals 300 kilowatt hours. So if it was directly proportional, doubling that, so 500 litres would be 600 kilowatt hours, but it's not, it's 630 kilowatt hours. So we've got those capitals on the watts. So doubling the litres does not double the energy used. Okay, so you always have to show the data. Does this data show this enough for the 2 marks? I've got the point, so doubling the litres is not double the energy used. Yeah, I suppose I could say that. So I suppose I could show it. So we could say, in brackets, 250 times 2 equals 500, whereas 300 times 2 equals 600, not 630. So something like that gives you that data. All right, new fridges are more efficient than fridges made 20 years ago. Give one advantage and one disadvantage of replacing an old fridge with a new fridge. Ignore the cost of buying. All right, new fridge. If it was more efficient, it means that more of the it's going to cost us less because we're going to be wasting less energy, aren't we? So less energy is wasted, less input. So the cost to run will be lower. The disadvantage, it's hard to get rid of a fridge, pretty much. So what should we say? What should we say for that? So in terms of recycling it, dispose. So it will be difficult to dispose of the. I suppose it would just end up in landfill. But it's all the gases that are in the fridge that make it difficult to dispose of. Right, that's the end of that question.